Welcome to another Wednesday webinar from Microdrones. It's our pleasure to have you join today's presentation, Corridor Mapping Made Easy by Microdrones. I'm Brett Bergdorf, Director of Marketing in the Americas and New Markets for Microdrones. Joining me is Jaume Cazorla, our Regional Director for the Middle East and a Geospatial Engineer for MD Solutions. Welcome, Jaume. We're looking forward to this presentation.
Hello, Brett. Thank you for the introduction. I think that today we have a nice case study to review for corridor mapping.
I think so too. In fact, the case study that Jaume is going to walk us through is an undisclosed utility company that's planning to build a new pipeline over 4 miles or 6.5 kilometers of rugged mountain terrain. The MD Mapper 1000 DG was used to create the final deliverables of an orthomosaic in DSM. In today's presentation, Jaume will review the challenges of corridor mapping with a drone and how to overcome them. He'll walk us step by step through the Microdrones workflow. Then we'll discuss the execution of data collection and quality controls, followed by an overview of the final deliverables. At that point, Matt Rosenbaum, our US Southern Sales Manager, will join to help me go over Microdrones as a service and explain just how easy it can be to get started with drone surveying equipment. And then I'll have a special invitation for everyone who attended today's webinar. Throughout today's presentation, if you have any questions, please enter them in the GoToWebinar menu. And then at the end of today's webinar, we'll get back to you following the presentation. So first up, what are some reasons to use drone surveying equipment for corridor mapping? You can be more efficient and save time. You'll spend less time in the field collecting data. You can also stay competitive. Drone surveying equipment is becoming an industry standard. Customers are asking for drone surveying equipment, and smart companies are preparing to deliver. Very important, you can be much safer. You'll easily complete projects in areas that are difficult or dangerous to access, such as challenging terrain, crumbling structures, high locations, and areas affected by natural disasters. Also, you'll be able to complete your surveys while you're working. You'll no longer have to stop work and equipment to collect the data you need. And you can expand your offering. By incorporating various payloads and technologies into your system, you can increase the number of services and deliverables that you can provide for your clients. And probably most importantly, you can slash your post-processing times. Our systems enable you to post-process data in a fraction of the time. Our drone surveying equipment also provides powerful digital deliverables. With advanced aerial photogrammetry, you can create digital terrain models, orthophotos, and advanced point clouds. To get a better understanding, let's look at a real case study and the workflow for microdrones. Jaume, now I'll turn things over to you and let's learn more about using drone surveying equipment for corridor mapping.
Thank you, Brett, for the introduction. And let's jump today to our case study. In this case, we are going to see the corridor mapping for a company that needs to build a pipeline. Let's see. The first part is how is the Microdrones workflow. In this case, it's divided in 4 parts. In the first plan, we will plan the project, like using our tablet. In our office, we can plan or we can do it in the field. The second part will be to fly, like we will assemble the drone and do the data collection. In the third part, we will see how to process and create the final deliverables. And lastly, we will see how they look. And for this, here there is the workflow. We will use MD Infinity for the processing part, and mission planning, we will use MD Cockpit, and for the data acquisition, well, our drones. And let's start. The first part is to see the project overview. Like in this case, we have a corridor mapping project. When we mention corridor, means that it's a narrow, long path that we need to survey. This is an oil and gas company that wants to build a new pipeline. And this pipeline is through the mountain. Like we need to pass several mountains through the valley for 6 kilometers with and create a base map for this company. Right now, this company was using classic surveying for this task. This means that GNSS, RTK receivers, leveling, and total station. However, to do this for this case is an expensive and inefficient technique. No, that's why they were looking to switch to a more productive drone surveying. The requirement is they need the orthophoto and the DSM. The accuracy will be around 10 centimeters what they need. The orthophoto generated will need to have a GSD, or the pixel size will be 5 centimeters. And the coordinate reference system projection and vertical datum you can see there. The next part will be the mission and flight preparation, how we plan the mission. In this case, the first part, we get the project requirements from the client, the accuracy, the deliverables, and the area of interest. And in the end of this phase, what we are going to get is the processing parameters, flight parameters, and the errors that we expect for our project. Now, the requirements, this come directly from what the client wants. They want to use the technology photogrammetry. Deliverables will be orthophoto and DSM. The accuracy they want is 10 centimeters for each axis. The GSD, 5 centimeters. They want to collect all the data in one day, and the coordinate system projection and datum. Now, let's see the area of interest. This is the first thing that the client shared with us. They want to fly here. And as you can see, the area is in the mountains. We are flying through a valley, and we need to cross some mountains. And this is difficult in general to do it, even with a drone. Now, the corridor, as you can see, is around 6 kilometers, 6.5 kilometers, and the width of this corridor, they want around 200 to 250 meters, depends of the area. Now, it's a very irregular terrain in the mountain. The altitude about the sea level is between 1,100 to 1,400 meters. This means that the total slope from the lowest point to the highest point will be 250 meters. This is a very challenging project, and one of the main reasons is that when you are flying in the mountain, you will face several difficulties. For example, one of them will be the light of sight. Like, you need to see the drone at all the moment, but between mountains, this is a challenge. The second one will be the wind. Since you are working in the mountains, the wind will affect the drone and will vibrate. And the third one will be the thin air. As higher you fly, thinner is the air. This means that the drone needs more energy to operate. And we will see how we face and how we address each of the difficulties now during the planning phase. Now, let's see the full workflow of this payload. As I mentioned, first, we will do the mission planning. Next one, after we have the plan, we will go to the field and check that we can fly. We will assemble our drone, and we will set up our base station, and later we will do the data collection. The next part is when the drone lands. We have some data that comes from the drone. In this case, we have the survey grade GNSS and IMU data, or the raw trajectory, and the photos. And from the base station, we will have the survey grade GNSS data. Now, we will take this and we will go to MD Infinity Cloud. That is a Microdrone software online, where we will introduce this raw data. We will get the exterior orientation from here. And with this one, we can move to a photogrammetry software to create the orthophoto and DSM. In this case, in the first case is if you want to use Formap, that is Microdrones photogrammetry software, you can do it, or you can use any other third-party software. They are supported by our system. And with this, after we do the photogrammetry process, we will get the orthomosaic and the DSM. Now, processing parameters. This is a guidelines that we give to achieve our objectives. In this case, the first part will be the processing parameters. In this case, since the client has a geodetic network, like has a network through the valley, we want to put the base station in one of their control points. Like they have built some monuments that with very high accuracy, then we want to use that. And we will set up there our base station. The second one will be for the EO. This will be the projection, a coordinate reference system and datum that we want. The next one will be the orthophoto generation. In the photogrammetry software, we will set up the GSD at 3 centimeters. And in this case, we need to fix the calibration during the initial processing, since this is how we operate in corridor mapping. And these are the two softwares that we will use, MD Infinity and a third-party photogrammetry software. Now, we jump directly to the flight parameters. The first thing is the solution that we are going to use. In this case, is the MD Mapper 1000 DG. The first thing is because it's photogrammetry, and this is a client requirement. They want photogrammetry, not LiDAR. The next one is the versatility of this drone. It's small and easy to carry, especially in places like the mountain that with hard to access, this drone has an advantage. The next one will be the flight time, that we want something that can fly around 35 minutes. Since the air will be thin or thinner at 1,200 meters, we need some buffer. This solution, it allows for corridor mapping. And lastly is the stability of this solution, because we are expecting windy conditions in this project since it's in the mountain. The next thing we will check is the altitude for our flight. In this case, we chose 150 meters altitude. There is the why we chose this. The first thing is the image GSD. Since we want to create a GSD of 3 centimeters in the orthomosaic, we need to get an image GSD smaller. In this case, we aim for 2 centimeters. The expected accuracy for the system at this height will be from 4 to 6 centimeters. This means that it will meet the client requirements, is efficient. And the last thing, and this is just to mention, but the limitation of the camera. About this 150 meters altitude, this camera, the Sony RX1R2, will start to suffer, and the image quality, it's reduced by a lot. And lastly, here you can see in this table, like the GSD and the accuracy expected. This is roughly, like just to have an idea. And the image interval threshold. This is if you know the speed of your flight, that in this case we will see it later, but will be 5 meters per second. And the altitude, you can see the interval between one picture to another. In this case, the threshold is 1.7 seconds, and we are more than safe for this flight. By the way, most of this information that I'm going to talk about, altitude, the speed, MD Cockpit helps you. MD Cockpit is our software for planning. It will help you during the planning phase. But here in this presentation, I just show some plots that will help you to understand what I'm explaining. Now, the next thing then is the speed. In this case, we chose 5 meters per second. The first thing that we need to check is we are trying to keep the image smear or blurriness below 0.5 pixels. And here in the plot, you can see we are around 0.35 pixels. The next one is the image exposure interval, as I explained before. And now, why I got a conservative smear, like I'm aiming for 0.35, 0.4. This is because I'm expecting a strong wind, lateral wind for the drone will affect the quality of the photos. And lastly, the terrain is not totally flat. We are talking that we are flying through the mountain. This means that the altitude will not be totally constant. Like there will be some areas that might be a little bit higher than 150 meters. That's why, to keep safe the image smear, we chose this speed. The next part will be to talk about terrain following. In this case, this option is the only way to survey a mountain area with a high altitude variation. In this case, for our project is around 300 meters. This means that with constant height, this project wouldn't be possible or will suffer a lot, especially in this case, we will also want to keep constant the GSD. That's why terrain following is essential for this project. For the overlap, we will use the minimum required by the solution, that will be 80-40, and we need to achieve at least 200 meters corridor. In this case, as you can see in the plot, we are aiming to get at least 250 meters corridor. The flight up finally will be a corridor with only 2 strips or flight lines. Like this will be the most efficient flight path that we can make. The next part will be to see the targets or the GCPs or checkpoints. In this case, we aim to have around 10. Here you can see in the 2 images the type of GCPs that we establish. The requirements will be 1 in the beginning of the corridor, 1 in the end of the corridor, another in the intersection between different flights, and lastly, we recommend another GCP every 500 meters. This is not mandatory, but is recommended, especially for very long corridors. Now we will see how long it will take approximate our plan. We estimate that the total plan and flying will be around 4 hours, the flying part. We estimate that we will require 5 flights, and this we can do it using the MD Flight Performance app from Microdrones. That mainly here, as you can see in the screenshot, you put your payload, you put at what altitude above the sea level you are going to fly, the temperature, and the weight of your solution. And it will estimate how long it can fly. In this case, it estimates that the battery will work around 37 minutes. This means that all the flights that we plan needs to be below 37 minutes. Why below? Well, the first thing is that you need to have in consideration that the drone needs time to go to the start of the mission, from where you are standing till the beginning of the mission, and later come back. And another thing that the pilot needs some buffer or extra battery in case an unexpected event. That's why we will plan all our flights below 37 minutes, and we will see later what we achieve. And here are the 5 flights that we plan. As you can see in different colors, red to black, we plan 5 flights to cover all the area. Now, and this is a summary that everything I explained in the planning phase. We will use the MD Mapper 1000 DG, the length of the corridor, number of strips, altitude, speed, terrain following, overlap, the image GSD. We are aiming to get 2 centimeters image GSD, but we expect that in the worst case, we might get 2.5. The number of GCPs or checkpoints that we will set up will be 10, and the time frame to collect the data. Now, this first part that I explained is critical. Like the planning phase is critical for the success of a project. Like understanding every parameter and why we select it is a way to assure your success. Lastly, we are going to see what are the expected errors for our project. When we select 150 meters altitude with a GSD of 2 centimeters, this means that we expect an accuracy 4 to 6 centimeters for 1 sigma and higher for 2 sigma. The orthophoto generated the GSD that we expect to accomplish is 3 centimeters, and this error expectations is based on the system specification. Now we will see what our team did on the field. In this part, we are going to first input the flight parameters that I just explained in the previous section, and the output will be the flights or the data acquired. And here is the data collection. Here you can see how were the flights, all the flights together, and the flights in different colors. Now, the team on the field, they follow strictly all the parameters that we plan. Like they use the MD Mapper 1000 DG at 150 meters altitude, a speed of 5 meters per second. They use terrain following. They did 5 flights. Now, in this case, the target established were 26. We asked for 10, but the team on the field, they could establish more points. We will use them. The overlap will be 80 by 40, and the area covered like 6.5 kilometers. And here you have the flight time for each flight. As you can see, all of them are below 37 minutes. This is because the pilot needs always a buffer time in case of an emergency. And by the way, the air is thinner, like the flight needs to be a little bit more conservative. The next thing will be the field quality control. When the drones land, the pilot will get the trajectory file and the base station file, and we'll introduce it in MD Infinity Desktop. And they will check that there is no MU gaps in any flight. There is no missing images. They will also check that the image quality is good, like there is no blurry image or dark image, and the base station that is 100% fixed solution. And here, MD Infinity Desktop give us some of these answers. And if there is any issue, we need to repeat the flight. In this case, there was no issue for any of the flights. Now we are going to see how to process and visualize the data that we acquire. The first thing will be the targets quality control. The client, in this case, established 26 targets, but as we can see, 3 of them are out of the area of interest. This means that we will ignore them. And one of them, the number 9, is partially covered by a tree. We will also not consider that. And lastly, they established this using RTK, and we expect an accuracy on these GCPs from 2 to 4 centimeters, depending on the axis. Now, how to process the data that we got from the field? As I mentioned before, we are going to use MD Infinity Cloud and the module trajectory processing and EO generation. Here, you have a screenshot of how it looks. You mainly introduce all the raw data there, select your type of solution, and the technology, the processing technology that you want to use. In this case, for any corridor mapping, you need direct georeferencing. And from here, we will get a report. The first thing will be like the processing status for all the flights that needs to be 0. And later we will get also the trajectory RMS or errors for X, Y, and Z. Both are as expected. And we will check also that there is no IMU gaps, there is no missing photos, and we will do a image quality control, like to see that all of them are clear and there is no blurry image. Then we will jump to the next step, that will be the photogrammetry processing and the generation of the mapping deliverables. Here in the left, we can see an initial view of all the photos and the path of the corridor in the photogrammetry software. And here are the two deliverables that we are going to create. The first one will be an orthophoto, and the next one, DSM. Now, photogrammetry processing. The first part that we need to analyze is the initial processing QC, that is during the aerotriangulation and the bundle adjustment. Now, this is the errors that we got during the initial processing. Using in the first column, you can see without using any GCPs. The next one will be using one GCP, and the third column will be using 3 GCPs. And if we translate that to GSD, you can see that our error is between 2 to 4 GSD. Actually, it's 2 in X and Y and 3.5 in Z. And here we can see it, no GCPs. This is from the report directly. This ugly table is exactly from the photogrammetry software, what we can see from 1 GCP and 3 GCPs. This is measuring the checkpoints RMS. And we can see that the 3 results using no GCPs or 3 GCPs have a very similar statistical values. This means that the quality of our trajectory is very similar to the quality of the targets, or it could be even that the target's quality is even worse than our trajectory. That's why it doesn't matter how many GCPs we use during the initial processing, that these GCPs doesn't improve the quality of our trajectory. For this case, we will choose to use one GCP, the target XD10, to create the final deliverables. And this is because usually we always recommend to use one GCP for if you are using direct georeferencing technology. And here we have the 3 reports from the photogrammetry software in case you want to see. This is the control points and checkpoint results. This is just a screenshot from the report. The previous table was just a summary of this. And here you have if we use one GCP, and here the results if we use 3 GCPs. The 3 of them are very similar. Now, we will create the first deliverable that will be the orthophoto with a GSD of 3 centimeters. And here we have a full project view of the orthophoto created. And if we zoom, you can see the level of detail of this orthophoto. The next one will be the DSM. In this case, the elevation grid will be also 3 centimeters, an overview of the whole DSM created. And if we zoom in the same area, we can see the elevations. And lastly, and this is just an example, we also generated the contour lines for this project. We generated 5 meters contour lines. And here is a zoom of the intersection area. Now, in this part, we are going to do a quality control of our deliverables, what we produce in the photogrammetry processing. We are going to do some quality control before delivering the project. In this case, we will introduce the mapping deliverables we just created, the project requirements, that is what the client wants to achieve, and the expected errors that we expect. And what we are going to get is the accuracy assessment report and the project report analysis. The first thing will be the accuracy assessment. In this case, we are going to use a third-party GIS software to measure the GCPs directly from the orthophoto and the 3D point cloud. As you can see, we will open the orthophoto in the GIS software. We will go to one of the GCPs and we will measure and we will compare the difference. We do this in the 3D point cloud and in the orthophoto. And this is what we achieve. As you can see, in the first part, we have here the measure values for each target. This is what we got in the orthophoto and for the set in the 3D point cloud. And here we have our GCPs. And when we get some statistics, we can see that the error is between 3 to 6 centimeters. Again, the orthophoto GSD is 3 centimeters and the image GSD 2 centimeters. I put here the image GSD because if you remember, we are expecting an error from 2 to 4 GSD, depending the axis, error for our project. This means that we got even better than we expected. Now, when we do analysis of the errors that we got, and here we have, in this table is clear and easy to see. Here we have the requirements. Like we need an orthophoto of 5 centimeters GSD, we got 3. And the accuracy decline spec is 10 centimeters in each axis. This is what we expected, an image GSD of 2 centimeters that we achieved. We achieved 2 to 2.5, and here is the error that we expect, and this is the error that we achieved. This means that the project actually meets the client requirement. After that, we will create an independent accuracy assessment report that will be delivered with the final deliverables. In this case, we will give the orthophoto, the DSM, the 3D point cloud that we generated. And because in this project, we have, they wanted to see the accuracy assessment report, we also added. And we can say that this project was successful. Now, let's review the final deliverables. We had the accuracy assessment that I just saw. We have the orthomosaic, the DSM, and here I create a small video to see the final deliverables. In this case, here is the orthophoto combined with the DSM, and it creates like a 3D model that you can see how was the corridor. In this case, you can clearly see the high difference and how hard was to survey this. Lastly, before passing to my colleague, I just want to briefly talk about direct georeferencing technology. Now, this technology comes from airborne photogrammetry. We just adapted to drone photogrammetry. Now, some features of this technology is that this is the only tool that is going to allow you to do corridor mapping with 1 or 2 fly lines. Like any other georeferencing technology will need at least 4 strips of them. This solution has been crafted with this technology for corridor mapping. Like if you are looking to do corridor mapping, this is the best technology in the market. And just to compare, if you are using a project with PPK technology that is very common in drone photogrammetry, this means that you will have a GNSS receiver, but you don't have IMU for the georeferencing. This means that when you are doing a corridor, you will not be able to do 2 strips corridor. You will need to do at least 4 strips corridor, which requires a longer flight time and longer processing time. Then thank you very much, everyone. I hope you enjoy my part on this webinar. I will hand over now the presentation to my colleague, Brad.
Thank you very much, Jaume. That was a very informative and detailed presentation. At this time, I'd like to introduce Matt Rosenbaum, who is our Microdrone sales manager for the Southern United States. Welcome, Matt.
Thanks, Brett.
Together, we're going to talk about Microdrones as a service.
So what Microdrones as a service is essentially it separates the hardware and the software, and it allows for both hardware as a service and software as a service, meaning you can rent the hardware or purchase the hardware and pay for the software as you go. Now you can actually get into it at a much more affordable rate, both renting it and purchasing the hardware and paying for the software as you go.
Well, let's take a look at that selection process, Matt. Today we talked about the MD Mapper 1000 DG as a service. So you'd step one, choose which integrated system you want to use for your mapping and drone projects. Then your second step is to select how you prefer to pay for that surveying equipment. And like Matt said, now we offer two options where you can either buy it, where you retain full maintenance and upgrade responsibility, or now you can rent it, where you'll enjoy a convenient hardware as a service agreement, and Microdrones handles all the maintenance and upgrades. Then you pick your data processing plan, whether you want a pay per project based on the projects that you're working on, or if you're a heavy user, maybe you use our unlimited option. Matt, let's look at a quick example what happens when you buy it.
So if you want to buy the hardware and own the hardware, you can still do that. We're Microdrones as a service isn't taking that away from you. So if you want to actually still own the hardware, what you're going to do is you select our buy it as a service route. And what you're doing here is you're buying the hardware, meaning you own the drone, own the payload, and you own the batteries. And then comes with a 1-year warranty. Maintenance is also included for 1 year. On the survey equipment processing side, it does come with, your mission planning software, so MD Cockpit, as well as safety updates and bug fixes for 3 years, and then access to MD Infinity to choose what type of post-processing that you're going to do, be it unlimited or pay per flight.
And today, if we're talking about the MD Mapper 1000 DG, we like to call this our drone mapping machine. With the buy it option, you can get into an MD Mapper 1000 DG for as little as $25,000 to get started.
That's right, Brett. It's a great value considering what you're actually getting in the hardware that you're getting on this system.
Now, one of the more exciting options that we're getting a lot of feedback and response to is the rent it plan. Under the rent it plan, Microdrones continues to take ownership of the system, which you get to use for 24 months. You pay for it monthly, and that includes the drone and the payload system. Training, shipping, and batteries are not included in the price. However, all the maintenance and updates are managed by Microdrones and included in your rental price.
That's right, Brett. Think about, just like leasing a car. You have the company behind you. If you have any issues or whatnot, if we can't figure out the problem or support you, if you're having an issue, we're going to make sure to get you a system back in your hands so you're limited downtime. So there's big benefits of the rented program. All of what you just said, and also that monthly cost is so low. You can rent this product for as low as $1,042 a month. You can pay for it monthly and then pay for your processing as you go as well, or build it into the cost of that on an unlimited basis.
Great. As Matt talked, we wanted to also, and Matt started to talk a little bit about our MD Infinity data processing options. That's what these next couple of slides are going to reference. So MD Infinity is a powerful processing tool that can help you quickly and efficiently process your geospatial data from your Microdrones mapping equipment. And that includes trajectory processing, georeferencing, and bore site calibration. And then in addition, with our MD Infinity custom services, we can provide strip adjustment, precision enhancement, point colorization, and as Matt talked about, and we'll dig into a little bit deeper, our new format services to help you quickly process orthophotos.
You bring up a great point. One of the big things that we've been working on here at Microdrones over the last couple of years is our format technology. And format stands for fast ortho mapping, like you stated. With photogrammetry, one of the big sticking points with it is it takes a lot of time to process the data. So if you now, with a technology like Format, something that could take you hours upon hours or even days sometimes to produce an ortho, you can bring that down to, matter of seconds when it comes to producing orthomosaics now. You might sacrifice a little bit on the quality, but still with these products, you're still, you're going to get a very high resolution ortho, especially from the RH1, R2 on board the DG, or even utilizing the cameras on our other systems as well. You make an investment in Microdrones technology, you're going to be able to have access to all these different tools by utilizing the direct georeferencing payloads that we have from a photogrammetry standpoint, and make it comparable to the speed of processing LiDAR. With LiDAR, it's a much quicker workflow, and that's a big selling point against photogrammetry. But now when you have tools like Format, you're able to actually produce those same data sets in similar time spans that you could with LiDAR.
Right, and here are your options to get into MD Infinity and choose how you want to process your data. And this is one of the really nice things about Microdrones as a service, is that we're making it easier and more convenient for you to build those costs into the projects that you're working on. So if you prefer to pay per use, then you'd want to use our pay per project option, where you simply pay per project online using a token system every time you want to download and use one of our data processing modules. The user pays tokens for usage of the modules, and then you can use the MD Infinity platform online. All the upgrades and updates are included, and we make sure you start out with 20 tokens when you're starting a new account. Now, for you heavy users who are going to be processing on a continual basis, and maybe you have a lot of jobs in your pipeline, then you'd want to use the unlimited option, right? Again, this is paid monthly, and now your usage is unlimited for 12 months, and you're able to use it both on the desktop and online, where all updates are included.
And like we kind of stated before, with Microdrones as a service, it makes for adding new payloads and different payloads that much easier, because you're going to be so well, built into the Microdrones as a service platform and the MD Infinity platform, that you can add different payloads, and going from one thing to the next is going to be super easy for you to do, which will allow for you and your company to grow with Microdrones. That's been kind of our selling point in the past. We've been around a long time. We're going to make a product that can grow with you. Now with Microdrones as a service, you can make that a much smaller investment, get into our products much easier than in years past, and then grow even easier because all of the platforms are integrated into our MD Infinity and Microdrones as a service platform.
Now I'd like to present a special offer for everyone who attended today's webinar. We're calling this our corridor mapping special offer. So in exchange for your attention and learning about using drones for your mining and surveying work, we have an extra incentive for you. Here's what you do. Schedule a meeting with your Microdrone sales professional, complete a needs analysis, and then attend a training session that's been customized for you based on your specific needs. In exchange for this, Microdrones will issue a voucher to be applied against your purchase, so long as that purchase occurs before December 31st, 2020. Then, your options are either a $1,000 voucher for future purchases on the MD LiDAR 1000 or MD Mapper 1000 series, or you can choose a $3,000 voucher to be applied towards future purchases on the MD LiDAR 3000 or MD Mapper 3000 series. Again, we'll need the purchase offer no later than December 31st. Should you have any more questions, please contact your Microdrones regional sales manager to take advantage of that special offer, or you can email mason.styles@microdrones.com. At this time, we'll conclude today's presentation. I'd like to especially thank Jean-May and Matt for their help.
Thank you, Brett. It was my pleasure to be here.
Thanks, Brett.
For any other questions, we'll get back to you shortly right after the webinar, and we're looking forward to working with you, and thank you for joining us today.